Hello everyone. In this video session, we are going to continue with confidence intervals. And here we are going to work on to construct a confidence interval in estimating a population mean. So before we start with theory, we are going to do a little recap of the things which will be need. So the recap is the one which I did in the previous session on the video. Talked about point interval estimates, confidence interval, confidence level, and margin of errors. So I'm going to have a quick recap of these, and then we will construct a confidence interval to estimate a population mean. Okay, so let's do a quick recap. So what is a point estimate? A point estimate is a single number that is a best guess for the population parameter. For example, we will use the sample mean as a point estimate for the population mean. So, but it does not give us a clear picture of how likely or how best this estimate is. So that's why we go and look at interval estimates. Interval estimates give us a little leeway and give us a little range of values to be more comfortable with it. So what is an interval estimate? It's an interval of numbers within which the parameter value is believed to fall. And the range of values are the ones which we add or subtract to the point estimate. And the ones which we add or subtract is called the margin of error. It's much more useful than the point estimate as it helps to gauge the accuracy of the point estimate. Now, point estimate and interval estimate together help us to get a confidence interval. Now, and the third thing we talk in a confidence interval is the confidence level. How confident we are in the interval of values which will be used in estimating the population parameter. So as I said, a confidence interval includes three things. First is the level, confidence level. That means which tells us the uncertainty of the sampling method. Then we talk about the point estimate, which is nothing but the sample statistics. And then finally, the margin of error. So these three things together give us the confidence interval, which is given by this formula. Confidence interval is point estimate plus minus the margin of error. This is the most important thing. Now, we prefer this to point estimates, the confidence interval, as it gives us the precision of the estimate as well as the uncertainty. Now, this uncertainty is called the probability part of it, and we give it a name called confidence level. What does confidence level do? The confidence level tells us that the particular sampling method is going to give us a confidence interval which includes the true population parameter. It is the confidence we get that, oh yes, the true population parameter will be within that range of values. And we denote the confidence level by 1 minus alpha. The alpha is the uncertain part of it, remember. Now, for example, if I say alpha is 0.05, remember this means 5%. Then the confidence level is 0.95 or 95%. And how would we interpret? We would say we are 95% confident that the interval will cover the true parameter. And as I said, the confidence interval has three parts, and that is, remember, confidence interval is the point estimate PE plus minus the margin of error. Now, this margin of error is the one which includes the uncertain part, and that uncertain part is given by the Z-score and the standard error. So this is the one. The margin of error is further divided into two parts. A critical value from the given distribution and the standard error of the point estimate. Now, once again, what do you mean by standard error? Standard error is estimated standard deviation of a sampling distribution, and we denote it by SE. Now, how would we interpret a confidence interval? As I said, a confidence interval is a point estimate plus minus margin of error. So once again, I'm going to recap the example I did last time in my other video. Here it is. We would like to estimate the percentage of APSC students who are left-handed. And suppose a sample size is 100, and out of those 100, 15 are left-handed. Hence, the proportionate of the sample proportion or the point estimate is 15% for the population parameter. And suppose the margin of error, which we found over there, was 0.0587. So what's the confidence interval? It's the point estimate plus minus the margin of error. And we're using confidence level to be 95%. So that's my confidence level, 1 minus alpha. So what is this going to give us the interval? The interval is 9.13% and 20.87%. So with this confidence level, that we say we are 95% confident that the true percentage of all left-handed students at APSCO, is between 9.13% and 20.87%. Now that was just a recap of things we have done earlier. Now we come to the point which this video is about, is to construct a confidence interval to estimate a population mean. Okay, so we're going to estimate a population mean. Now there are two things will happen. One, when we know the population standard deviation, and the other part is when we do not know the population standard deviation. So in the first part, we are going to look at to construct a confidence level when we know a population standard deviation for the estimation of population mean. Okay, let's go ahead. What does it say? Now, a confidence interval for a population mean with a known standard deviation is based on the fact that the sample means for a large n, if it is a large n, that means automatically the population is approximately normal, or if we have a small n, then we assume that the underlying population is normal. If these two things are happening, only then we can apply the method. Remember that. So here, when we assume that we know the population standard deviation, and we are looking at the sample size, either my sample size is very large, that means 25 or more, then automatically we have an approximate normal distribution. But if my sample size is not large, then it should be given that distribution from which the sample is taken is a normal distribution. Otherwise, we cannot apply, as I said, this method. Now, here we know the population standard deviation sigma, and when we are given the population standard deviation, we use the standard normal distribution to calculate the margin of error, and then finally construct this interval. So let's go ahead and look at what the formulas are. Okay, so we know the confidence interval is what? Point estimate plus minus the margin of error. As we are looking at population mean, so that means our point estimate is going to be what? The sample mean, which is x small bar. So the sample mean will be the point estimate for the population mean. What's the margin of error? Remember, margin of error is made with two things, standard error and z-score. The standard score is sigma over square root n. Remember, it is the sampling standard deviation of the sampling distribution. Please remember that. Let me write it down again if you forget. This is the standard deviation of the sampling distribution. Okay. Now, what is the formula? How do we do it? So here's it. So if I have a confidence interval for a large n or in a small n which the population is normal, The formula is x bar minus z alpha by 2 times sigma over square root n, comma, x bar plus z alpha by 2 sigma over square root of n. So this is the confidence interval. This is the formula for us. Now this interval will contain mu, that is the true population mean, with probability approximately 1 minus alpha. Remember, this is the confidence level we are talking about. Now, how do we find z-scores? So in order to find a z-score, this is what we do. To find a z-score that puts an area equal to the confidence level in the middle of the standard normal distribution, suppose z is a standard normal distribution. So I want to find a z-score when alpha is 0.05. What we normally do? So if alpha is 0.05, the first thing we do is we find alpha by 2, 0.05 by 2, which is 0.025. Now we want to find the z-score or the critical value which is related to alpha, which is 5%. So what we do is we go ahead, draw the standard normal curve, and then take alpha by 2, and that alpha by 2 is on either side, and in the middle is the confidence. So remember, alpha is there. So what is the confidence level? 1 minus alpha, which is 1 minus 0.05, 0.95. So this, guys, is 0.95. This whole part is 0.95. So this part is alpha by 2, and this part is alpha by 2. Together they make it 0.05. Now remember, we do this way because our normal distribution is symmetric at the mean, and the mean is where the mound of the bell shape is. So what we need to do is we will need to find this value or this value. The only difference between these two values is this is positive and this is negative. The number value is the same. Now to find the z alpha by 2, what we do is use this formula, inf norm, and when you find the z alpha by 2, that means all the area under the curve to the left of this value, z alpha by 2. So this is, now remember, this one is 0.95, and this alpha by 2 is the area. Remember, this is the area, which is the probability that we are not confident. That is 0.05. The total value is 0.05 plus 95, which gives me 0.95. And it is a standard normal distribution, just put 0 and 1. You get the value to be 1.96. That's how you find a z-score or the critical value. Now let's go ahead and do some examples over here. Now suppose the scores on an exams in statistics are normally distributed. Okay, it's easily given, it's normally distributed, and we do not know the population. It has an unknown population mean, but a population standard deviation of 3 points. Okay. A random sample of 36 scores is taken, and that gives us a sample mean of 68. We would like to find a 90% confidence interval for the true population mean of this statistics exam scores. The first thing you have to remember is what formula we have to apply. The first thing is we are talking of mean. Okay, great. Then, do we know the standard deviation? Yes, the population. So that means my confidence interval is a sample mean plus minus z alpha by 2 times the standard error. Okay, this is the formula. Now if you go a little deeper here, it is x bar plus minus z alpha by 2. What is the standard error? This SE, remember, is the standard error. If you forget that, let me write it down again. Standard error is sigma over square root n. So this is our formula. In order to get this formula, we need to first write down the parameters, and then we just plug the values here. Let's look at what's x bar. X bar is given to be 68. we need to know alpha. Now remember, my alpha is, or 1 minus alpha. You remember, this is confidence, 90% confidence means 1 minus alpha. Okay. So we are given 1 minus alpha to be 90% or 0.9. That means, what is my alpha? 1 minus 0.9? 0.1. Alpha by 2? 0.1 by 2, 0.05. Okay? So we're getting the values. Okay. Now, we need Z alpha by 2. So that means we need Z of 0.05. Now, if you remember, that formula is inf norm. Now, when I do these things, I normally try to create a little, normal curve. And I'm like, oh, this is my Z alpha by 2. Z 0.05. That means the area behind this is 1 minus 0.05. So it is going to be 0.975. 95, not 0.975 if I'm right. Yeah, it's 0.95, no, not 75, sorry guys. And 0 and 1. And what do we get the value to be? We get it to be 1.645. Okay, so we got the Z. What is sigma over square root n? That's a standard error. So let's write down the standard error, which is sigma over square root n. And sigma is given to be, what is it? Population standard deviation of 3 points. And sample size 36, square root 36, which is 3 over square root 36, 0.5. So we have got all the values. Now we just plug it in this formula. Okay, x bar, which is what? Whereas it's x bar, 68. Plus minus Z alpha by 2, 1.645. Times 0.5. When you do the math, you get 68 plus minus 0.8225. So that's my confidence interval, 68 plus minus 0.8225. So how do we interpret? We say we are 95% confident that the true population mean lies between 68 minus 0.8225 and 68 plus 0.8225, which gives the value to be 67.1775 and 68.8225. Okay, so once again, we are 90% confident that the true population mean of the statistics exam scores lies between these values, 67.1775 and 68.8225. Remember, in order to get these values, you have to do all this work. Okay? Let's do another example. 30 randomly selected students took the biology final. If the sample mean was 82, the population standard deviation was 12.2. We would like to construct a 99% confidence interval for the true population mean score of all students. Now remember, in this one, we are not given that the distribution is normal or not. But if you remember the central limit theorem, it says that if you have sample size greater than or equal to 25, then that distribution has an approximate normal distribution. Now, as the number of students are 30, that means it has an approximate normal distribution. We are given the population standard deviation, so that means what will be the formula? X bar plus minus Z alpha by 2 times sigma over square root n. So that's the formula we are going to use. Okay, so we need to know the values. We need to just plug in the parameters. Let's write down the parameters. Now, my alpha, 99%. That means what is my alpha? Is 1 minus alpha is 0.99. Alpha is 0.01. And my Z alpha by 2 is 0.005, which is 0.01 by 2. And what is my Z alpha by 2? Is inf norm. Now, we need to know what should come over here. So remember, we're going to create this little bell-shaped curve. We need Z alpha by 2. Okay, that means this one is what? It's 0.99 plus 0.005. So it's 0.995, 0 and 1. So let's go ahead, our calculators, to do the math for us. So we're going to do second and vars. Take the cursor to number 3, press enter. It's now 0.95. That's not the number we need, is 0.995. What's the mean? It's 0. The standard deviation, 1. The tail, now most of you may not have it. You just go to paste, but here I have a little latest version, so it gives me a left. So I just go to the paste, enter. I get 2.57. These are so 2.5758. So when we write down the values here, this is 2.5758. So we got Z alpha by 2. We need to find sigma over square root n. So sigma over square root n is what? Sigma is what? Sigma is 12.2 and n is 30. That is 30 randomly selected students. That's square root of 30. We get the value to be 2.2274. Now plugging it, that's it. So x bar is what? We had it to be 82, sample mean. 82 plus minus 2.5758. Remember, this is a point, times 2.2274. We get this to be 82 plus minus 5.73. So what's the confidence interval, guys? Oh. So the confidence interval is 82 minus 0.573, so that's 76.2627 and 82.7373. Okay, remember this is the confidence interval I am talking about. Okay, now let's look at one more example when we are given the population standard deviation. It says a random sample of 60 female members, okay, that's my sample size, of health clubs in Los Angeles showed that they spend on average 4 hours per week, average means mean, doing physical exercise with a population standard deviation of 0.75 hours. We would like to find a 95% confidence interval for the population mean meal. So the moment you see the word confidence interval, things which you should in your mind is, what is the interval we're looking at? Population mean or proportion? So here it is mean. So that means my sample mean would be x bar, plus minus. Then we have to think about, am I given the population standard deviation or not? And here, yes. So that means my formula would be z alpha by 2 times sigma over square root n. Okay, so once we have written down the formula, after that it's just writing down all these values. So before we plug in the values, my recommendation to you is, go ahead, write down what are the values for each of these parameters. Now, x bar, simple, is the sample mean, which is the average 4. Now, we know n, which is 60. Population standard deviation, sigma, which is 0.75. Okay, so now this one sigma over, then we need alpha. Now to find alpha, what are we given? We're given 95%. 95% is 1 minus alpha. That's the confidence in level, which is 0.95. So that means alpha is 0.05. Alpha by 2, 0.025. Okay, now from here we need z alpha by 2, which is z.025. Now before we do the work, guys, we need to make sure, remember, to find z alpha by 2, this whole area to the right is 0.025. That means the area to the left is 1 minus 0.025, which is 0.975. So to find z alpha by 2, what are we going to do? Write inf norm 0.975, 0 and 1. What do we get? Let's go ahead, take your calculators out. Second vars. Take the cursor to number 3. Press enter. It's 0.975. So I'm going to write 0.975. The rest is the same, 0 and 1. Do not worry about the tail. You may or may not see it. So just go to the paste. Press enter. It's 1.9599. So I would go 1.96. Okay. So this one is 1.96. Now we've got all the terms. We just plug in the values. So x bar is 4 plus minus z alpha by 2 is 1.96 times sigma. Sigma is 0.75 over square root of 60, which is 4 plus minus, when you do the math over here, guys, we are going to get that to be 0.1897. So what is my confidence interval? 4 minus 0.1987, which is 3.8103. And when you add 0.1897 to 4, 4.1897. So that's our answer, guys. So we are 95% confident that the true population parameter, mu here, mean, is going to lie between 3.8103 to 4.1897 hours. Remember, it's the problem over here is how many times on average the members of the club are doing physical exercise. Now, this was doing problems with population standard deviation. But in reality, when we do not know the population, can we even figure out the population standard deviation? So because of it, we are going to talk about how to estimate a population mean with the, not the known, with the unknown, with the known sample standard deviation. Here it is a sample standard deviation. So that means we are going to use the sample standard deviation in place of the population standard deviation. And when we have that scenario happening, we say that we're using the student t distribution. Okay, that's the part to keep in mind. So when we are reading a problem, we have to see what is given to us. Are we given a population standard deviation or are we given a sample standard deviation? And if you're having a sample standard deviation, that means we are using a student t distribution. Okay guys, let's go ahead and focus on it. As I said, in reality, we do not know this, but we estimate the population by a sample standard deviation. So our standard error is now s over square root n. Because we are now replacing the population by a sample, we are going to have more errors. So we are going to replace the z-score by a t-score. Now, and also the confidence interval is going to be a bit wider. So this distribution is called a t distribution with n minus 1 degrees of freedom. N here refers to the sample size. Now, before we do problems constructing this confidence interval, let's do a little bit about t distribution. What is a t distribution? Okay, the t distribution is very similar to a normal distribution. Keep first that thing in mind. And the t distribution, if you notice, as the degrees of freedom, as the sample size is becoming more and more, it is becoming closer and closer to the standard normal curve. Okay, because this represents a bell-shaped curve, so we are going to have the area. So what is the area under the curve? So the area under the curve, guys, is now given by the area under the curve over here is 1, because this resembles a standard normal curve. Do you see that? The curve is never going to touch the x-axis. It is symmetric about 0. That's where it is. That's like a normal standard normal distribution. Now, the probabilities here depends upon the degrees of freedom. As the degrees of freedom increase, the t distribution looks more like that of a standard normal distribution. So if I have a degrees of freedom above 30, the t-score is very, very similar to the z-scores. Now remember, z-scores and t-scores. Z-score is when we are having a population standard deviation, and a t-score is when we are having a sample standard deviation. Okay, so what's the formula? Now, if the random sample is very large, or if it is coming from normal distribution, then the confidence interval is x bar minus t. That's the first change. Alpha by 2 multiplied by s, that is the standard deviation. Sample standard deviation. So remember, this is the sample standard deviation. And the t, guys, over here, this one is the t-score. So that's the only difference between the one we had earlier when we had the population standard deviation. So just replace the z-score by t-score, the population standard deviation by a sample standard deviation. We have the answers. The only thing we had over here is how many degrees of freedom. That means n minus 1. N minus 1 is, that's how it's related to the number of sample size. Okay, now let's look at how to do some little bit math here to find t alpha by 2s and degrees of freedom. We're going to do a little bit math here. Okay. Now, what is the meaning of alpha? Remember, alpha is the probability that a standard normal random variable is larger than Z alpha. Alpha is the probability that a random variable with t distribution is larger than t alpha. The previous one was when we are having a standard normal variable, but this one is for t distributions. That means we're having a sample standard deviation. So if I want to find the t values, how would I do it? So t alpha is inf t 1 minus alpha and the degrees of freedom. We're going to do a little practice over here, guys. Okay, now degrees of freedom, remember, is n minus 1. So if n is 10, what is the degrees of freedom here? 9, this will be 22, and this will be 60. So if I want to find out what is the t value when it is 0.1, alpha 0.1, remember what's the formula here? The formula is inf t, this is how you do it. So the alpha is 0.0, this one is 0.01, 0.1. So this one is 0.99, 0.9. Okay? So, because remember the total area under the curve is 1. Okay. So what do we get? We write this as inf t 0.9 and 9. Now plug in our calculators. Let's get our calculators out. Second inverse. Now you go to the number 4. Press enter. It will give me the area. How much is the area? 0.9. What's the degree of freedoms? We had 9. Take the cursor to paste. Enter, enter. We get 1.38. Okay. That's the answer for this one. 1.38. What about t.05 and n is 22? 23 degrees of freedom is, notice, 22. Okay, so this sense, what are we going to do? We're going to do second verse, take the cursor to 4, press enter. Now here, it is not 0.9. Remember, it is 0.05. So in this scenario, what is needed? For this one, guys, it is this one, I want t alpha. So alpha here is 0.05. That means this one, the one which you have to write is 1 minus 0.05 is 0.95. So the formula is inf t 0.95. How many degrees of freedom? 22. Okay, let's go ahead and do this one here. So it's 0.95 degrees of freedom, 22. Cursor to paste, enter, enter. 1.717. So what's the answer? 1.717. Let's look at this one. T 0.025. That means this is 0.025. What's this part? 1 minus 0.025, which is 0.975. Do you see that over here? Okay, am I right? 1 minus 0.025, 7, 5, 10, yeah. Okay, so what are we going to write here? You're going to write here is inf t, okay, so go ahead guys, write it down. .975 on your calculators, degrees of freedom 60. The answer comes out to be, okay, let's see what the answer comes out. almost 2. So 2. Okay. Now this was a scenario where the sample size was given. If the sample size is not given, but we're given the degrees of freedom. So what I've done over here is I've kept the same alpha, increased the degrees of freedom to see how closely, as I increase the degrees of freedom, the value for this t-score is very close to the z-scores. So let's do this one. So t.05, remember it's all the same of the same alphas. So 0.05, which is 0.95. Now, the first one is inf t 0.95. The degrees of freedom is 5. Okay, so when you plug in the calculators, you will get, and I would like you to do on your own to check the answers what I get, 2.015. Now next one I'm going to increase the degrees to 50. Let's see how it impacts the answer. So when I do this one, I'm getting 1.675. Wow, that's a big difference. Well, let's go to 100. What does that give us? In t.95 100, we get 1.660. Okay. Now let's look at these were t-scores. Now I have a z-score. I'd like to know how close when I increase the degrees of freedom is to the z-score. Now remember the z-score is what? Inf norm. 0.95, 0 and 1. When you plug in the values, you get 1.6448. Notice as I'm increasing the degrees of freedom, it's coming closer to the z-scores. Okay, now we would like to do write down a formula, confidence intervals for population means when we are given the sample standard deviation. So it's x bar plus minus t alpha by 2 times s over square root of n. Remember this one is the standard error. This total is the margin of error. And this is the point estimate. Okay, let's do some examples now. The 2008 General Social Survey asked what do you think is the ideal number of children per family. 678 females who responded had a median of 2, mean of 3.22, and a standard deviation of, now this standard deviation is a sample of these 670 females, 1.99. So, the question is, what is the point estimate? Point estimate means x bar, 3.22. What's the standard error of this sample mean? It's s over square root n. 1.99, n is 678. That comes about to 0.0764. Now what is the 95% confidence interval? Remember, it's x bar plus minus t alpha by 2, and standard error is this. So we only have to find t alpha by 2. Let's do the t alpha by 2. Now, what is my alpha? Alpha is 95. So it's 1 minus alpha is 0.95. Alpha is 0.05. Alpha by 2 is 0.025. So if I want to find the normal curve, that is t.025. Now, t.025, what's the formula, guys? It is inf t. Now, this whole area, remember it is 0.975, which is this one, is 1 minus 0.025, which gives me this. What is the degrees of freedom? I have 678. This is n. Remember, this is n. Degrees of freedom is 1 less than that, 677. And then plug in the values. What do we get of this value to be? We are getting it to be 1.963. So plugging in the values, 3.22 plus minus T alpha by 2 is 1.963 times 0.0764. We get this to be 3.22 plus minus 0.149. So what is our confidence interval? You subtract and add to 3.22.149. You get it to be 3.07 and 3.369. Okay guys, so that means we are 95% confident that the population mean will be between these two values of the confidence interval, 3.07 and 3.369. Let's go ahead and do more of these problems. Okay, so for a class project, some students are doing a survey to find out the average number of hours, average number is mean, an APSU student spends studying each week. They take a random sample of 91 APSU students and compute a sample mean of 5.4 hours per week with a standard deviation of 1.2. Keep in mind, guys, when you read the problem, until unless it says population standard deviation, by default, it is always sample standard deviation. So let's write on the things we come from here. And we would like to find a 95% confidence interval. So the things which are given to us as a sample mean is going to be 5.4. The number of samples are 91 students. The sample standard deviation is 1.2 hours per week. And our confidence level, 1 minus alpha, is 0.95. That means alpha is 0.05. That means T, because this is a sample, so T alpha by 2 is T.025. Now here, that means inf T, you know how to get the value 0.975. You can look at the previous slide. The degrees of freedom will change. It depends upon this end, which is 90 now. Previously, it was a different number. Okay. Now, the formula is, let's write on the formula. We have to just plug in now. X bar plus minus T alpha by 2. The standard error is sample standard deviation over square root of n. Let's plug in the numbers. 5.4 plus minus T alpha by 2. When you put this values, you are getting it to be 1.986. Times S, which is 1.2 over square root of 91. So we are getting 5.4 plus minus, to the math, 0.25. And so the confidence interval is 5.19 and 5.69. Okay. One more example over here. It says for 30, that means that's my n. For 30 randomly selected Rolling Stones concerts, the mean gross earning was $2.27 million. The sample standard deviation was $502,100. We would like to interpret a 96% confidence interval for the mean gross earnings of all Rolling Stones concert. Okay, you got to be careful. This is in millions, this is in thousands. So we have to change the millions into this thousands, okay? Remember, 1 million is 10 to the power 6. Okay, so 2.27 million is equal to 2.27 times 10 to the power $6. Either you change this into millions or you write 2.27 in terms of hundreds and thousands. Okay, so let's write down what's given. N is 30. The standard deviation sample mean is 2.27 times 10 to the power 6 because we are changing it to the normal number, not in terms of scientific notation. The sample standard deviation, little s, is 502,100. The alpha is here 1 minus alpha. The confidence interval is 96%, guys. So 1 minus alpha is 0.96. Alpha is 0.04. Alpha by 2 is 0.02. T alpha by 2 is T.02, which is inf T. Now remember, we need to make our little bell-shaped curve. This is 0.02. That means this is 1 minus 0.02, which is 0.98. Degrees of freedom is 1 less than the number of sample size, 29. And we get this value to be 2.15. Okay? Now, we just have to plug in the formula. The formula for the confidence interval, sample mean plus minus T alpha by 2 S over square root n. So this is 2.27 10 to the power 6 plus minus 2.15 times S is what? Big number 502,100 divided by square root of 30, which we get 2.27 times 10 to the 6 plus minus, we get this to be, when you do the math here, 197091. So this is our confidence interval. Okay. Now, very important to keep in mind that we are doing all these problems assuming that the population distribution is normal or approximately normal. In real life, many of these distributions are far from normal. So we have to be very careful when we are working with these problems. So if your sample size is very small, say it is less than 25, be cautious of applying these problems we are doing. Well, thank you.